All right, everyone, welcome back. We're getting ready to talk about example number 3, but before we do that, we're going to have to talk about some postulates first. Now, postulates, that is a really, really fancy name, postulate or axiom. And what that is a statement that is accepted as true without proof. That is what a postulate is. So it's a statement that is accepted as true without proof. Now we're going to be talking about a lot of different postulates throughout this year. And what you're going to need to do is you're going to have to create note cards. So for each postulate, you're going to want to make a note card. Okay, so one note card for each postulate. All right, and then we're going to talk about theorems and corollaries and all different types of things. But you're going to have to make like a note card or a little flashcard for each one. So here we're about to talk about 3. So that means we're going to make 1, 2, 3 note cards or flashcards. Okay, these are something that you need to have with you. You need to go over these so that you're able to commit these to memory, okay? Because the more familiar you become with postulates and theorems, the easier this class is going to be. If you don't put in that time, then all of the problems that you're going to try to do are going to be very, very difficult because you're not going to remember it, okay? So you need to go through and you need to study these things. You need to commit them to memory. It's very, very important, vital for being successful in this class. Maybe some of you aren't used to doing that, but you're going to have to change if you want to be successful in this course, okay? So the first postulate, and it's just something that's accepted to be true, is that through any 2 points, so this is chapter 1, lesson 1, and this is the first postulate. Through any 2 points, there's exactly one line. All right, so let's look at that. These are my little things that I'm going to use as points. So basically, through any 2 points, I can draw exactly one line through them. And that looks like it's like true, right? Okay, what if I move this point and I kind of move it in the air a little bit? Well, there's still one line that can be drawn through them. Okay, well, what happens if I move this one in the air, maybe over here? Well, there's still one line that can be drawn through them. So through any 2 points, there's exactly one line that can be drawn through those. So just imagine those are points. I know they're little cube things, but just imagine they're points for me. Okay, so that's a postulate. It's just, it's a statement that is accepted to be true. Okay, let's talk about the next one. It says, so this is 1-1-2, so chapter 1, lesson 1. It's the second postulate we're talking about. Through any 3 non-collinear points, okay, there's that word, non-collinear. Collinear means 3 points that are on the same line, so this obviously means these are 3 points that are not on the same line. So through any 3 collinear points, so look here, if we had 3 collinear, they would be on the same line and we could draw a line through them, right? But we're not talking about that. We're talking about 3 that are non-collinear. So something that you can't draw a line through. So I can't draw a line through all 3 of these, right? I can draw a line through 2 because through any 2 points, there's exactly one line. That's that first postulate. I can draw a line here. I can draw a line here. But I can't draw a line through all 3 because they're non-collinear. So what this says, through any 3 non-collinear points, there is exactly one plane. This is my plane, my clear little plane, that connects them. And there you go. There's that clear little plastic that's setting on them. That is the plane that is connecting all 3 of those. Now I can move them into a different place that is non-collinear, and that there's still a plane that connects them, but not one line. One line can't connect them, but a plane. So 3 non-collinear points are connected through a plane. Let's try to move it, try to get a little tricky or something. Here, and still there's a plane that connects all 3 of them. Okay, so now what I'm going to try to do, what if I have this one go, and this is the only way I can try to, let's say this point here, this one's in the air, okay? So I know it's kind of grounded like this, but I want you to imagine that this point is in the air. let's see if there's a plane that connects all three. And if you can see, this plane is connecting all three. It's just kind of slanted like this. And I know it's kind of difficult, but it's more slanted, all right? Or if I, you know, I could change it and add one over here, you know, and so this is kind of in the air, this one's in the air, this one's kind of on the ground a little bit, and then it would just be, there would be a slanted plane, so the plane would be slanted, but it still would connect all three. Okay, so through any three non-collinear points, there's exactly one plane connecting them. So you can kind of see this little kind of visual right there, that's like a plane, and those are the three little points that are non-collinear. Okay, this next one, it says if 2 points lie in a plane, so here we go, here's my little clear plane, and we have 2 points that are lying in the plane. No, let's use the same color. Okay, those are my 2 points lying in a plane. Then the line containing those points is also lying in the plane. So if we have 2 points, then the line, you know, it might be easier to kind of look like that. The line containing those points is also in the plane. All right, so here's my plane, there's the points, there's the line. Maybe it would be like this. Maybe I could do it like this and have it like that, and then the line is also in the plane. Like that. So yeah, any 2 points that lie in the plane, then the line containing those points is also lying in the plane. So that it's just a picture that looks like that. So that's the third postulate. It's just something that's accepted to be true. Okay, so we're going to be applying these throughout your homework set. Let's go ahead and look at what something like that might look like. So let's look at example 3. Example 3 says, name a line that passes through 2 points. Oh wait, example 3, identifying points and lines in planes. Okay, so name a line that passes through 2 points. So this picture, I would say line XY passes through 2 points, right? And that's it, that's the answer. All right, let's look at check it out 3. Check it out, example 3. It says name a plane that contains 3 non-collinear points. So there's that word, right? Non-collinear means 3 points that are not in a straight line. Okay, name a plane that contains 3 non-collinear points. So if I was looking here, I could see here's this plane, right? And it looks like G, H, and F are points that are in that plane, and they are non-collinear. So I could say, it says name a plane, so we could say plane G, H, F. That's a plane that contains 3 non-collinear points. Or, you know, we could say plane R. Okay, that plane R is also a plane that contains those 3 non-collinear points. All right, so that's example 3. Good job. We will see you in a little bit for example 4.